Okay, we're going to continue looking at solving exponential equations. Now, we did do this earlier on, back in exercise 5C. What we're doing a bit differently this time is we're solving it when we're not getting nice whole number answers. So our answers now will end up being in terms of logs, if we're doing it tech-free, or in our calculator, we would get it just to 2 decimal places. This is going to be quite a quick exercise. It's not going to take you too much time, so we'll get stuck in and we'll see how this goes. Okay, so first of all, we want to talk about how you would use your CAS calculator to solve 5 to the power of x equals 9. So I'm just going to write this up here so we don't lose it. Where will I write it? 5 to the power of x equals 9, and we're wanting to solve this on our CAS calculator to get our answer correct to 2 decimal places. So this shouldn't be anything that's too difficult. So if we have a look, you'll have to get your calculator screen up. Okay, so here it is. Now, in this case, we need to go to the main menu. I'm going to clear everything that's there. Remember, it is always a good idea to also clear all variables. If you've perhaps stored x as something, you've stored a value as x when you've been trying to use things, perhaps in another subject, perhaps at another time, it's a good idea to clear them so that this will work. I simply type the equation. So 5 to the power of x, sorry, I should use the actual variable here, and you can use the one on your hard keypad, that would be an easier way to do it, is equal to, what are we wanting to do? Equal to 9. Okay, depending what's down the bottom here, if I'm keeping this in decimals, so here, that will give me my answer to 2 decimal places. If I had it in standard mode, it would give me an exact answer. So let's leave it in standard for now. Highlight, we select interactive equation, and we're going to solve. So we're clicking solve here. We're wanting to solve it, yes, okay. So we get our answer in terms of logs of 2 log 3 over log e of 5. Remember, ln is meaning log of base e. Now, to get it in this format is due to something called the change of base rule. Now, the change of base rule is not something that is part of the study design. It is something I'm happy to go through if you'd like, but it's not something you need to know. So that's one potential answer. But like it said, we want to know how to solve this on our calculator to 2 decimal places. So I can click this little button up here, 0.5 to half, that's changing from approximate to exact. So we can get the answer of 1.37, correct to 3 decimal places, x equals 1.37. So it's not too hard, and we've got that value there. Continuing on, we can now work out what this would give us in terms of logs if I was solving it in a tech-free situation. Okay, so if we are solving this in a tech-free situation, sorry, just give me a minute. Yes, okay. So if we're solving this in a tech-free situation, we've got, let me click back here again. Okay, 5 to the power of x equals 9. Now, to be able to solve this, I need to take the log of both sides. In order to cancel out this 5, what I would be looking at doing is taking log of base 5 of both sides. Remember, with equation solving, whatever I do to one side, I need to do to the other. When this happens, this means the x, because it's a power, can be written in front, one of our log laws. So we get x log base 5 of 5 equals log base 5 of 9. Now, log base 5 of 5 equals 1, so we get the answer x equals log base 5 of 9. And if we put that into our calculator, we would get the same answer as 1.37. I realise this doesn't look exactly the same as the answer our calculator gave us before, where we had log base e, ln, but it is the same answer. It's just a different way of writing the same answer. One thing to be careful of with logarithm equations, or inequations in particular, now this isn't one that's written here, but if we were doing something else, so for example, if we were solving an inequality And particularly if I had a value of, so if we're looking at this one, 0.7 to the power of x, plus 1 is greater than 0.5, for example. Okay. We would start in a similar way, so we would try to solve this in a similar way. And perhaps we don't tend to take log of base 0.75. So if we were trying to solve this in a different way, sometimes, and this is important if you're in a multiple choice situation and there's a number of different answers and you need to try to see if your answer matches one of the ones that was given in the multiple choice options. So we could solve this the same way we were solving earlier. Okay, so we could take log of base 0.7 and log of base 0.7 over here. But it isn't generally done. Usually our bases are greater than 1 and we tend to take either 10, 2 or e, or our other whole number values. What we could do instead, particularly if this was in a multiple choice situation, we could take log base 10 of both sides, okay? Greater than log base 10 of 0.5. Again, this x plus 1 can be written in front. Notice it's still kept together, it's still in brackets because the power is kept together. Now, when I'm wanting to solve this for x, the next step would be that I would need to divide both sides by log base 10 of 0.7. So if I divide both sides by log base 10 of 0.5, okay, we do need to be careful about the value of this, because remember, when we're dividing, if we divide by a negative value, if this value is negative and I divide, the inequality sign would have to swap. If we think back to when we drew our log equations, log base 10 looks like this. It had an intercept here at 1, 0, which means that when x is equal to 0.7, I'd be getting a value over here somewhere. At this point, the y value, the value of log base 10 of 0.7, would be found here, below the y, below the x-axis. It would be a negative value. Because this is a negative value, it means that the direction of the sign, the inequality, would have to swap. So our final answer to this question would then be x, we can subtract 1 from both sides, is less than log base 10 of 0.5 divided by log base 10 of 0.7 minus 1. Okay? So this is what we've got here. Again, you could do it on your calculator. That's straightforward. You would go straight to an answer. This is just a different way of solving them. There are lots of other ways you could approach it, but it is worth keeping in mind in case there was a multiple choice question asking if you were to solve this equation, what could be the answer? If there's answers looking something like this, it is something that you would have to be aware of as well. Okay, well that's all from this. It is quite short. In class we'll be working on exercise 5G. Remember to bring any questions along and we'll discuss them together.